If a tree falls in a forest and no one is around to hear it, does it make a sound? This age-old philosophical riddle has puzzled thinkers for generations, challenging our understanding of reality and perception. This question isn't just a whimsical thought experiment, it probes the very nature of existence and our role as observers in the universe. It asks us to consider the relationship between the physical world and our sensory experiences. Sound, we know, is a vibration that travels through a medium, such as air, and is then detected by our ears. These vibrations are converted into electrical signals that our brains interpret as sound. But what if there were no ears to hear? Would the vibration still exist? The vibrations would still occur, but without an observer, the experience of sound would be absent. Most would say yes, arguing that the existence of sound is independent of an observer. They would claim that the physical processes that create sound waves are objective realities, unaffected by human presence. But what if we take this question to the quantum realm, where the very act of observation seems to influence the outcome of events? In this microscopic world, the rules of classical physics no longer apply. What if reality itself behaves differently when observed? In the quantum world, particles can exist in multiple states simultaneously, a phenomenon known as superposition. The world of quantum mechanics, the physics that governs the universe at its smallest scales, is a realm of perplexing paradoxes and mind-bending possibilities. It challenges our conventional understanding of reality. Here, particles can exist in multiple states at once, blurring the lines between what we perceive as real and what exists as a ghostly potential. This duality is at the heart of quantum mechanics. It is a realm where the act of observation seems to play a crucial role in shaping the very fabric of reality. The observer effect suggests that the mere act of measuring or observing a quantum system can alter its state. This perplexing interplay between the observer and the observed lies at the heart of one of the most profound mysteries in modern science, the observer effect in quantum mechanics. It raises questions about the nature of consciousness and its role in the universe. Does consciousness, the very essence of our being, somehow influence the world around us at the most fundamental level? Could our awareness be intertwined with the fabric of reality itself? Or is there a deeper, more subtle explanation for this strange entanglement of mind and matter? The answers to these questions could reshape our understanding of the universe. The implications of this question extend far beyond the realm of theoretical physics, challenging our very understanding of the nature of reality and our place within it. It touches on philosophy, metaphysics, and the essence of existence. Join me as we delve into the heart of this quantum enigma, exploring the experiments, interpretations, and philosophical debates that have captivated scientists and philosophers for over a century. Together, we will uncover the mysteries that lie at the intersection of observation and reality. Our journey begins with a seemingly simple experiment that would forever alter our perception of the quantum world. The double-slit experiment, a cornerstone of quantum mechanics, reveals the strange and counterintuitive nature of particles and waves. Imagine a wall with two narrow slits cut into it. This setup might seem simple, but it forms the basis of one of the most intriguing experiments in the history of science. Behind the wall is a screen that can detect the passage of tiny particles, such as electrons. This screen is highly sensitive and can capture even the smallest interactions, providing us with a detailed map of where each particle lands. Now, picture firing a beam of electrons at the wall. These electrons are tiny, almost unimaginably small, and they travel at incredibly high speeds. What kind of pattern would you expect to see on the screen? Would it be random, or would there be some order to it? Common sense suggests that the electrons would pass through the slits and create two distinct bands on the screen, much like tiny bullets leaving their mark on a target. This is what we would expect if electrons behaved purely as particles. However, the quantum world has a different story to tell. When this experiment, known as the double-slit experiment, is actually performed, something truly remarkable occurs. Instead of two distinct bands, we observe an interference pattern on the screen. a series of light and dark fringes that is characteristic of waves, not particles. This pattern is similar to what you would see if you were to drop two pebbles into a pond and watch the ripples interact. This pattern arises because, in the quantum realm, particles like electrons can behave as both waves and particles, a phenomenon known as wave-particle duality. This duality is one of the cornerstones of quantum mechanics and challenges our classical understanding of physics. But the mystery deepens if we try to observe which slit each electron passes through. By placing a detector near one of the slits, the interference pattern disappears. This suggests that the act of measurement itself has a profound impact on the behavior of the electrons. The act of observation seems to force the electrons to choose a path, collapsing their wave-like nature and revealing their particle-like behavior. This is a direct manifestation of the observer effect, where the mere act of observing a quantum system can alter its state. This bizarre phenomenon, often referred to as the observer effect, is one of the most compelling pieces of evidence suggesting that consciousness, or at least the act of observation, may play a fundamental role in shaping quantum reality. It raises profound questions about the nature of reality and the role of the observer in the universe. It is as if the electrons know they are being watched and change their behavior accordingly. This idea challenges our traditional notions of objectivity and suggests that the universe at its most fundamental level is deeply interconnected with the act of observation. How can the mere act of observation, of gaining knowledge about which slit an electron passes through, influence the outcome of the experiment? This question has puzzled scientists and philosophers alike for decades. Does this imply that our minds, our consciousness, can directly affect the physical world at the quantum level? If so, what does this mean for our understanding of reality and our place within it? The double-slit experiment, in all its simplicity and elegance, reveals the profound strangeness of the quantum world and the deep mysteries that lie at the heart of our understanding of reality. It challenges us to rethink our assumptions and opens up new avenues of inquiry into the nature of the universe. As we continue to explore the quantum realm, we may uncover even more surprising and mind-bending phenomena that will further challenge our understanding and expand our horizons. The journey into the quantum world is just beginning, and it promises to be an exciting adventure filled with discovery and wonder.